Welcome to Physics in the AM. I'm Shindaka. Anyways, we started on work and energy, and all you have to remember is that work is force times displacement, and it has to be in the same direction. The displacement has to be in the same direction as the force applied. Now, power is what we're looking at now. Power is at the rate at which work is done. And you might recognize power, or you won't recognize this necessarily. Power is equal to the work divided by the time. But you might recognize the watt unit. Where have you heard of watts before? On devices. Give me an example of the wattage of some device that you might know of. Anyone else? Oh, come on. Nobody? Have you guys heard of watts? Pretty well anything that plugs in. Why? Because it tells you how much energy per second that's what the watts is. How much energy per second is being used. So if you use something that, well, here's something. You guys, when you guys were little kids, we were just in the process of phasing out old-fashioned light bulbs, incandescent they're called. And we are still packaging, and we're getting, and it's being phased out. By the time you guys are 80, I'm sure nobody will talk about this, but when you buy light bulbs, it'll usually say for the old people like me, equivalent to 80-watt light bulb, equivalent to 75-watt, 100-watt, 40-watt light bulb. Do you guys see that, or do you guys ever even shop for light bulbs? Because now it's measured in its better brightness, lumens, how bright it is. Before they used to measure, because actually you used way too much energy for the amount of light, is the whole thing. So they measured it in the energy usage. Okay, so you'll see boxes on your light bulbs that say 100-watt equivalent, the brightness of an old light bulb. Anyways, you've probably also heard of horsepower, right? Where do you hear about horsepower? Yeah, engines and stuff like cars. It's really a stupid thing because to compare it to horses, this must go back to the Henry Ford day when they called the car the horseless carriage or something like this, right? I don't know. Anyways, but before we get into this too much, we're going to pause the recording and talk about, watch a video. A student does 82 joules of work when lifting her text from the floor to the desk. Took her 3 seconds. That's pretty slow, by the way. Like, that's slow. But anyway. So I made this one pretty simple. How? But it's the first category. So it's as simple as 82 joules divided by 3 seconds. 82 divided by 3. I know it's less than 30. I'm just going to look it up because I'm 27. Let's just think about this. I'll just pause this for a second. The next thing is, I got a snippet of my power bill up here from a year ago. SAS power unit for work. Energy. Work energy, I'm going to call it here, is the kilowatt hour instead of the joules. And actually, SAS power sells you energy. Sask energy doesn't sell you energy. SAS power does. But we call it electricity. So on. Okay. How do they relate to each other? Well, how do they relate to each other? There must be this, like they must be measuring the same kind of thing. Well, let's do this out. 1 kilowatt times an hour. That's a kilowatt hour. That's typical for electricity around. What's a kilo mean? How many? Oh, so this is 1,000 watts times an hour. But we know what hours are. How many seconds in an hour? 60 60 minutes times 60 seconds is 6 times 6, 3600, right? 3600? I'm just doing one thing at a time. Uh, Now, if I multiply that, you get 3 million. Now, what is a watt times a second? Zero. What are watts? It's right above on the page. Joules per second. If you have, right, joules per second times seconds on the top. Cancels the second. It'll just be joules. So 1 kilowatt hour on your electricity bill is really 3,600,000 joules of energy. So you're actually getting that. Now, you see on my electricity bill, that was last year, September, October, 963 kilowatt hours. Okay. I just convert that to joules, but I don't see why. Okay. Just so you know. So what am I asking you to try? 9 and 12 on page 264 textbook. You can do this.